Okay. Guys, the circumference is the locus of points in a plane. I don't think that's right either. I think it's just a circle.
Okay.
Okay, so a circle is the set of all of the points that are the same distance away from that center point, the center of the circle. Okay, so a long time ago, a bunch of Greeks were like trying to figure out how to find areas of circles and stuff like that. And they did a bunch of tests on circles. And what they figured out is if they measure the radius and then they measure the circumference, which is like the perimeter, the outside of the circle, they were always related to each other by the same ratio. And that ratio happens to be the irrational number pi. And that's how they started to figure out what the heck pi was. Because they just didn't come up with that out of nowhere. It is the ratio of the parts of the circle, like compared to the other parts. It comes from the world around us. Okay. Hey, can we get all the phones put away? I know that I wasn't ready to start right away, but now I need the phones away. Thank you. Okay. So, you've probably seen these formulas before. We have this cute little formula where the circumference is pi times the diameter, or that the diameter is 2 times r. So the circumference is 2 times pi times r. You guys have seen those before, right? Okay.
Why is it so long?
We're not going to do it all, don't worry. That's what I was looking up one of the times I said that we were going to start and didn't. That's what I was doing. Okay. So we have to find the area and circumference of this circle, and then we're going to leave pi in our answer. So whenever we're leaving pi in there, that's an exact answer. Because the minute we start rounding, we're introducing rounding errors. Okay, so let's find the area first. We know that the area is pi times the r squared. So they're telling us that this whole segment from the outside through the center back to the outside, the diameter is 6. But we need the radius, which is only half of that. So what's the r? Yeah. So all we have to do is plug that into this little formula. So the area of this circle is pi times r3 squared. So that is 9 pi inches squared. Okay, our circumference is 2 pi r. Or just pi times the diameter, right? We could use either. But 2 pi r is like the more common one, so I'm just going to do that. So we know that our r is 3, so our circumference is 2 times pi times 3. So I can just multiply the 2 and 3 together because multiplication is commutative. And I get c equals 6 pi inches. Okay, this is a length. And this is an area. So if I were to take a little string and stretch it around the outside, this is how long it would be. It's a linear measurement, even though it's going around in a circle. Any questions about that?
Nope.
Okay, easy peasy lemon squeezy. Okay, find the area and a circumference of a circle with a radius of 8 inches. So we've got our little circle, Here's our center. Our radius is 8. We just need their formulas. So the area is pi times our r squared. So that would be, what's 8 squared?
64.
64 pi inches squared.
Can I use my straw?
Yeah. Okay, circumference. That's 2 times pi times r. We know r is 8, so 2 times 8 is 16 with a pi inches. Just plug and chug. Good? Okay. So a pizza making kit contains 3 circular baking, I think that's supposed to say stones, with diameters of 24 centimeters, 36 centimeters, and 48 centimeters. Find the area and circumference of each pizza stone. Round to the nearest tenth. Okay, so these are the diameters. So I'm going to make another column here that are the r's. How do I find the r if I know the diameter, the radius? Yeah, just divide by 2, chop it in half. So this is 12, this would be 18, and 24. Okay. And this time, the directions are telling us that we have to round to the nearest tenth. So I don't have my calculator up here, so I'm going to need you guys to be on it. So the circumference is 2 times pi times our radius of 12. And then round it to the nearest tenth. So that is 1 place after the decimal.
75.
What was it? 70?
No, yeah.
75.4.
75.4.
75.4, and this would be centimeters. Okay, the area would be pi times our r squared, which is 12 squared. So 144 pi.
452.4.
Okay, 452.4 centimeters squared. I think we should probably show everybody on the video real quick where the pi button is if they haven't found it already. Okay, so if I want to do 144 pi, I'm doing 144, and pi is right above the power caret underneath the clear button. So I have to hit the blue second button and then the little arrow button, the exponent caret, and then I can round. Okay. Do we need to do the rest of these, or are we good?
Pretty good.
Okay. We're just going to keep it moving, guys. If we need to go back and do some more at the end, we can. I've been told the videos are too long. It's fine. All right, we have to find the area of the shaded region. So what we're going to try to do is find the great big area of the rectangle, and then we're going to subtract away the stuff that's not shaded from it. Okay? So this area, so we're going to take the area of our big rectangle, and we are going to subtract away the area of our circle. And we're also going to subtract away the area of this cute little square. Does everybody see the strategy? We just find the whole thing and then we take away the parts we don't want. Okay, so how do I find the area of the big blue rectangle?
Height times base.
Yeah, base times height, length times width, whichever one you want. Basically, it's going to be 7 times 10. Okay, what is the area for the circle? This is the radius of 2. So the area of a circle is pi
So it's 4.
times r squared, so 2 squared. And then the area of the little orange square is just base times height, or the side squared, so 3 times 3. So I can just simplify all that. So my big blue rectangle, 7 times 10, that's 70. Does it say find the exact area or round or anything fun like that?
It says on there.
Okay. So this would be 4 pi. And then this would be minus 9. So it doesn't say that we get to round, so we are just going to have to assume that we want an exact answer. So we are going to leave pi in that answer. We have 2 like terms. Do you see that the 70 and the negative 9 are combinable? I can combine this one and this one. So 70 minus 9, that gives me 61. And then I just have to leave the minus 4 pi alone because I cannot combine those 2 terms. I can write them next to each other, subtracted from each other, one from the other, but I can't simplify it. And then does it say any units? No. Okay, so this is just units that we don't know, squared because it's an area. Any questions about that? Okay. Oh, here's a fun one. You get to review what we did yesterday. Friday.
Yes.
Friday. Okay, so we are going to find the area of the shaded region. So do you guys see that that's the circle minus the pentagon? So that'll be the area of the circle minus the area of the, oh my gosh, I don't know if I can draw a pentagon, guys. This is gross. We're just going to say pentagon. My drawing skills failed me. All right, how do we find the area of a circle? Yeah. So pi, did they give us an r?
Yes.
Yeah, they did. This is our radius of 6. Okay, the exciting part is the review part. So we have to find, boop, 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 boop. Okay, we have to find those central angles. Remember how we did this on Friday?
1, 2, 3, 4, 5.
Okay, so we've got 5 central angles. So we're going to take our 360 degrees and we're going to divide it into 5 chunks
72.
of 72 each. So each of these is 72 degrees. Okay, now I'm going to draw in my apothem. Boop, 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 boop. Okay, so the apothem chops each of those 72 degree angles into congruent. What's 72 divided by 2? 36. 36 degree angles. Okay, so this is not a 30, 60, 90 right triangle, so I can't use special right triangles. But I can use some trig. So my apothem is my A, and then my hypotenuse here is 6. Does everybody see that?
So where are we trying to find the base of it?
We are trying to find this because once we find that, we can just double it. You want to call that x? Okay, so that's x, and then this would be 2 times x. Okay, so the x is my opposite, and I have my hypotenuse. So which of my ratios uses opposite and hypotenuse? Opposite and hypotenuse, that's sine. Okay, so we're going to take the sine of 36 degrees and say that that is x over 6. I undo dividing by 6 by multiplying both sides by 6. And then I can put that in my calculator. So x equals 6 times the sine of 36. Make sure you're in degrees and not radians. So I'm going to go to mode, make sure that I'm in degrees. And I'm doing 6 times the sine of 36. I got 3.53. Okay. 3.53, which we now have to double. 7.06. Okay, that's my side length. Now I also need my apothem, right? Okay, so I got to solve for my little a. So I'm going to go back to my picture. Now I want the adjacent and the hypotenuse. Cosine. So cosine of 36 degrees equals my a over 6. So now I can just multiply both sides by 6 again, and we get a equals 6 cosine 36 degrees. 6 cosine 36 of 4.85. Okay, so the area of the pentagon is the number of sides times 1/2 times the apothem times the side length. Okay, so we just have to plug all that in. I've got 5 sides times 1/2 times the apothem of 4.85 times the side length, x, which is 3.53. Did I get all that right? What? Did I miss something? Okay, so I'm just gonna, I need you guys help, I need your help putting this in the calculator because I can't look at this in the calculator at the same time and my short-term memory is crap. So I'm doing pi times, what was it, 6 squared? Okay, 6 squared minus my 5 sides times 1/2 or 0.5 times 4.85 times 3.53. Thank you. So I got 70.30. Okay. So my total area after subtracting away the pentagon is, I already forgot, 70.30. 70.30 inches squared. Well, that was a fun one. Are you having fun yet? Okay. Do we need to do this one? Okay. Let's talk about sectors. For this one that we're skipping, you see that it would just be the hexagon minus the circle? Okay, so just kind of the opposite of what we just did. Okay, the area of a sector is a fraction of the circle containing the sector. All right, so let's say that I had, oh my gosh, my picture is terrible. I'm just kind of winging this up here. Let's say that I chopped my circle into fourths.
Hi, do you have Bella?
Let's say that I wanted to find this piece of the area. It's 1/4 of the area, right? Everybody can see that. Can you see that that is 90 degrees out of the total 360 degrees? Okay, would you put that 90 out of 360 in your calculator and reduce it for me? 90 divided by 360, enter, math, enter, enter. You see it's 1/4, right? So when we're finding the area of a sector, we're just taking the degrees that we want, dividing it by 360 to get what part of the area we actually want. Because it's not always going to be some pretty number like 90 over 360 where we can tell, well, duh, it's 1/4. It's going to be something gross like 131. But we're doing the same thing. We're just going to take 131 and divide it by 360. It's just not going to be a nice, cute number like 1/4. Is that okay with everybody?
Mm-hmm.
Okay. So once we have that ratio, we just multiply it by the area of the entire circle. That's it. That's all sectors are. We can do it. So let's take this one. We have to find the area of sector HGJ. So HGJ is this whole thing. So first we need the area of the whole circle. So it is pi times our radius squared. It looks like our radius is 12. So I'm getting that our area is 144 pi. So now to find the area of the sector, that was just the whole circle, right? That's our whole thing. Okay, we will at the end. We're going to round at the end. If we have the option to not round until the end, we should take it, because otherwise we just get rounding errors that whenever we're multiplying, they get bigger and bigger errors. Okay, so we have 131 degrees out of the 360 degrees possible. Okay, and we're going to multiply that by the area we found, 144 pi. So we can just put that whole shebang in the calculator. So 131 divided by 360 times 144 pi. And it said nearest hundredths. Is that right?
Yeah.
So 164.62. And this would be meters squared. Easy enough, right? Hold on, let me see how many more. All right, we're doing one more. So, the area of our sector is 25 over the total 360 that were possible, right? Do you guys not have this one?
No, we do. I just flipped to the wrong page.
Okay. Over 360 degrees, okay? And then we're going to multiply that by the total area. So our radius is the 5 feet. So times pi times 5 squared. You can just put that whole thing in your calculator. I'll do it with you.
Maybe 25.
It would be 25 pi. Yeah. So 25 divided by our 360 times pi times, was it 5 squared? Did I forget anything? Does it say to round to the nearest hundredth again? Okay, so 5.45. 5.45 square feet. That's it. You guys thought this was going to be bad today. It's not.